If this is your first time learning about data center networks, you may be familiar with what a client and a server is. For instance, a server is a specialized device that serves up an application inside of a data center, but you may not necessarily be familiar with which form factors that servers come in. So over time, we actually started with what we call a rack mount server. And a rack mount server is just that. It's a server that you can put in a 4-post rack inside of a data center. And they come in different formats. They measure a rack based in U's. For instance, if I had a 42U rack, I would know that the size of that rack based on a 24U rack, which might be half the size. And servers themselves take up a certain number of U's, for instance, 1U or 2U. In this example, we're looking at a 1U rack mount server. You may also notice that the server is optimized. It's a little bit different than a client. It doesn't have, for instance, a monitor that's plugged into it or a keyboard plugged into it. So these are actually made to run in the data center in what we call a headless design, where they can run without a monitor or keyboard directly connected to them. But as you can see, up in the left-hand corner, I have a place that I can plug in a monitor or keyboard, and a lot of times we call this a crash cart, into that server in order to get to the console if I need to. You can also see that I've got a row of disks in front of the server, and they're able to be plugged in or taken out if one fails. And they run in what we call a RAID configuration, or a redundant array configuration for the disks, so that I can actually lose one without losing the server. I can also see on the back that I have things like redundant power supplies and redundant fans that can be hot swapped if my server fails. I see that I have places to plug in video and network or USB ports. And I can also see that I can add things to a rack mount server very easily, because I've got a little bit of extra space inside that server to be able to add things like PCI devices such as network cards or maybe a video card or something to that effect. In servers, I have the capability to plug in additional adapters like we were just talking about. So for instance, if I wanted to add more network adapters, I could do that. If I wanted to add more video capability, I could do that. If I'm using a network adapter, a lot of times I don't know what types of media I'll find in the data center, so I'll use a transceiver to plug in that network adapter and then connect to the switch at the top of the rack or at the end of the row inside of my data center. Servers are also made to accept large amounts of memory depending upon the server. Some accept more than others. For instance, I can take different sizes of DIMMs and then plug them in the slot based on how the server manufacturer tells me I can do that. And then based on the size of the DIMM or the number of DIMMs that I can put in the slot determines how much memory I can support. So in this case, these 8 DIMMs will give me 128 gigs of memory. If I plugged in another 8, I would get 256 gigs of memory. And obviously another 8 I would plug in, I would get 384 gigs of memory. The one thing to note with servers is as I add more memory, I make it an unoptimal configuration. So for instance, if you notice here with the 8 DIMMs, I got 256 gigs of memory, and I still get the speed of 1866 megahertz, which is a very fast speed. If I add an additional 8, it actually knocks me down to 1333. So server administrators have to weigh whether or not they want more memory versus more performance in some situations, and that's going to depend on the application that you're looking to run on your servers. The other thing to keep in mind is that you're always weighing cost versus performance. You can buy different processors for servers, and based on the processor that you want to buy, the latest and greatest is going to be very expensive, where there's always a sweet spot of kind of just behind the curve of this processor gives me almost as good a performance, but for much less cost. So for rack mount servers, they've been around forever. We have a ton of different configurations based on the use of that server. For instance, the lower left-hand side here, that might be a web server. Web servers usually don't need a bunch of horsepower, but we usually need a lot of them. So we may use this C220 M3 for our web servers, and we may buy a lot of them and put a bunch of them in the rack and scale that application out. Whereas all the way to the right here, I can see that I've got my 460, which is just a huge server, which may be great for databases or something that requires a lot of CPU and a lot of memory. The one on the top, the C240, if I need a bunch of disks, that might be the server for me. So all these different servers come in different configurations that are optimized for the application that we wish to deploy them for. This is an example of what a legacy server pod might look like. So I might have my application servers there on the left. Like I said, they don't need as much horsepower or memory, and we just go ahead and plug a bunch of those guys in, and then we connect them to the switches at the top of the rack. Same thing on the right. If I need something with more horsepower or more disk for a database server, that server is going to look a little different, but I'm still plugging them in a rack. I can't fit as many of them, and then I connect them up to my switches up top, and I'm ready to go. Now, as you start to scale out this architecture, it actually becomes quite a bit to manage, because every server has to connect to the switches at the top of the rack, and then I have to manage all those switches inside the architecture. Every server that I buy, also, I have to repay for power supplies and pay for fans and have to connect management connections to them every time, and more cabling means a more complex network architecture, and that means that I have more routing and more VLANs to maintain in my architecture. I also have to update these servers. So the more and more individual servers that I add, I have to upgrade the BIOS, I have to upgrade the firmware, I have to have what we call KVM or remote connectivity to each one of these servers. So as you can see, as I start building these rack mount architectures out, if I need a lot of compute, it can become very inefficient and it's hard to scale. So over the last 10 years, what we've actually done for a lot of our workloads is we've actually started to move away from the rack mount architecture and move into a blade architecture. And the thinking behind that is similar to the thinking for a modular-based chassis in the network, that we would put all our resources in one place and hopefully reduce the amount of power supplies, reduce the amount of switching we were buying, and reduce the amount of management that we had. But unfortunately, as blade servers started to evolve, we found out that it was actually, we were just able to fit more computers in one spot. We weren't actually saving on the number of servers and switching that we had in the infrastructure, that we actually ended up having more switches per server than we would have with the rack mounting, and that the management was there, but it wasn't reduced or it wasn't integrated. And basically what we ended up doing is taking that rack full of servers that we used to have and shrinking it down and basically calling it a blade architecture. And it resulted in a lot of complexity in the data center. This is where Cisco saw the need for a new product, a product that we designed from the ground up called UCS. And in the next lesson, we're going to learn all about how UCS helps us solve the problems that we encountered with the legacy blade architecture. So please join me for the next lesson, 4.8, Introduction to Cisco UCS.